So looking at volume application problems can be a little challenging. I would say try your best to break things down, write down your associated formulas, and find what you need. So with this problem, they give you a birdhouse. So they're trying to show you a little picture of the birdhouse over here. And they give you a two-dimensional cross-section. So with that cross-section, you can get all the information you need in order to find the volume of the birdhouse. So some key language they're telling you is that it's a cylinder, okay, and a cone. So think of both of those shapes and find formulas for them. They both have a radius of 8, and the cylinder has a height of 12. So I went ahead and filled in everything, but I'll go with you step by step of where this is coming from. So I said if I added the two volumes together, I could first start with the cone. You could have started with the cylinder, doesn't matter. So the cone formula is always 1/3 pi times the radius squared, which we know is 8, times the height of the cone, which I didn't know, so I'll go back to that in a second. Plus, I did the cylinder volume, which is going to be pi times the radius squared, there's the 8 again, times the height of the cylinder, which happens to be 12. So I used this figure to help me out. I had enough information about the cylinder, but I had to take the fact that the radius was the same for the cylinder and the cone, put that into my figure, and I could then use that to find the height of the cone. So I used a little bit of trigonometry. So using the 62 degrees as my reference angle, the height, I made that at x happens to be the opposite side, where the radius happens to be the adjacent side. That's why I chose tangent. Did a little cross multiplication, so if you want to throw this over a 1, go for it. And put it in my calculator. Didn't round too early, went out a few decimal places, and then it says round to the nearest cubic centimeter. So I believe it says that. Yep, nearest cubic centimeter. So put that in my calculator, and it ended up being 3,421 centimeters cubed. So then the next part of this is they want you to answer a little question about it. So you're going to use that volume again, so keep that in mind. So you are filling the birdhouse with bird seed that weighs 0.41 ounces per cubic centimeter. So there's a rate. We've been working on those. So I would write that out as 0.41 ounces per cubic centimeter. Put your little fraction in there, or you can write it 0.41. And then OZ is just the abbreviation for ounces. You can write out ounces if you want. Some students like to put per 1 centimeter cubed, whatever makes more sense to you. If you only want the bird seed to weigh 950 ounces, can you fill it 65% full and not exceed this weight limit? So let's take it one step at a time. So say I wanted the weight of the entire birdhouse. Let's ignore the 65% for a second. You could first find that. You could say, well, the volume is 3,421 centimeters cubed. If I multiply that with my weight of the ounces per the volume, I could cancel those out. So goodbye centimeters cubed. So this is the weight of the entire birdhouse, okay, in ounces. Now, it talks about this 950. We'll get back to that in a second. They want you to only fill it 65%. So the next step I did is I just multiplied that ounce amount by 0.65, there's your 65% as a decimal, and I got 911 ounces. So yeah, you can absolutely fill it 65% full and not exceed the weight limit of 950 ounces. The other strategy, so I kind of scribbled it down over here, you could also say, let me find 65% of the volume to begin with, and then multiply that with the 0.41 ounces per centimeter cubed, and you would still get 911. Because you're doing multiplication, it's commutative, order doesn't matter. It doesn't matter if you apply the weight to the entire amount first or the 65%. For me, I think this just made more sense in my head naturally to find the weight of the entire birdhouse. I hope that helps.